Okay, let's do the 27th question. Okay, so find the limit of the function when x is approaching 5, where the function f of x is equal to modulus x minus 5. Okay, now when we take the number line and let this point be 0, and for negative values, when x is negative, okay, or x is less than 0, the function will be modulus x minus 5. And for the positive values, or when x is greater than 0, x is greater than 0, and this is for x less than 0, okay, this value, this will be modulus x minus 5. Okay, now because we have only one function, it is the same for all. But one thing is that when we put a negative value here, it changes to positive. Okay, so this can be written as, changed as minus x minus 5. Okay, modulus x can be written as negative x. Okay, and for the positive values, when x is positive, you can write it as it is, x minus 5. Okay, now we can write this function as, rewrite this function as f of x is equal to, the function will be minus x minus 5 when x is less than 0, and x minus 5 when x is greater than or equal to 0. Greater than or equal to 0, 0 is considered as positive. Okay, x minus 5. Okay, this side, and this one for this 5, left side. Okay, now again, if you draw the number line, let this be 0, and this is minus x minus 5 less than 0, and this is for the right side, x minus 5 for x greater than 0 or equal to 0. Now we have to find the limit of the function as x approaches 5. So 5 is positified somewhere here. Let this be the point 5, and this is 0. Now we have to find the limit at this point, limit of the function at this point, when x is approaching 5 from the left side and from the right side. Okay, I'll do it one more clearly. This is 0. Okay, sorry, this is 0, and this is 5. Okay, now x is approaching 5 from the right side, and x is approaching 5 from the left side. Now the function of the positive area is greater than 0 is x minus 5. This is the function. Okay, so there is no use of the function less than 0. Okay, here. So now let this distance be h, the length be h, and let this distance be h. Okay, so the position of x will be 5 plus h. Okay, 5 plus h, and here the position of x will be 5 minus h. Okay, so now the limits at this function will be, let's first we'll calculate LHL, the left hand limit. So LHL will be limit of the function as x approaches 5 from the left hand side, okay, is equal to limit of the function, limit of f of, instead of x, now we write 5 minus h, as h tends to 0, which is equal to limit. Now in the function we replace x with 5 minus h. Okay, so we write it as 5 minus h minus 5. Here we write 5 minus h minus 5. Okay, h tends to 0, which is equal to, now replacing h with 0, we get 5 minus 0 minus 5, which is equal to 5 minus 5, which is equal to 0. Okay, so this is the left hand limit. Now the right hand limit, RHL. So limit of the function as x approaches 0 from the right hand side is equal to the limit f of 0 plus h. Okay, x is replaced with 5 plus h, replaced by 5 plus h when h is approaching 0, which is equal to limit. Now we'll replace this x with 5 plus h. Okay, so 5 plus h minus 5, h tends to 0, which is equal to, now we'll put the value of h. Okay, so we get 5 plus 0 minus 5, which is equal to 5 minus 5, which is also 0, which is equal to the RHL. Now here the LHL is equal to RHL. Therefore we can say that limit of the function exists as x approaches 5 or x is equal to 5. Okay, at this point. Okay, that's it.